math friends. Today we're going to look at how you calculate the arc length. If we think about the parts of the circle that we've talked about the diameter that goes from one side to the other passing through the center, and we've talked about the radius that goes from center to rim. We've talked about a chord that goes from one side to the other without passing through the center. And we've talked about circumference, which goes all the way around the outside. And we've talked about area that covers the whole inside. And then finally, we've talked about this arc length idea, where it just is walking on a piece, not the whole thing. So when I think about all those different pieces, the two that I really think go together are circumference and arc length. Those two are kind of friends. They're buddies, because arc length is just one little piece of the whole circumference. So if I want to find arc length, I start by finding my circumference. So I'm going to go ahead and think about my circumference formula. If I need to find the arc length in these two circles, in this one I want to find the arc length from A to B. So I want to walk just on this piece. So I'm going to think about circumference being pi times d. All right, and the first thing I need to know is, what's my diameter? Well, if I know my radius is 3.6, I know my diameter is equal to just 3.6 times 2, because that's halfway, and now I want to go all the way. I need 2 of them. So I go to my trusty calculator, and I take my 3.6 times 2, and I get 7.2 meters for my diameter. Now I certainly can calculate my circumference. I simply take 3.14 times 7.2. Again, trusty calculator, 7.2 is already in there. I can just say times 3.14. And I get 22 and 608 thousandths. And that would be meters, because circumference, you're walking around the outside, it's just in meters. So if I think about that, the circumference gave me all the way around my circle, but I don't want to go all the way around. I just want to go from A to B. And if I think about how many pieces that I have that are the same size as from A to B, I think about these pieces. The purple piece right here, that would be the same size. The green piece right there would be the same size. And this blue piece would be the same size. So I have 1, 2, 3, 4 pieces, and I just want one of those, 1/4. So I'm going to take this and I'm going to divide it, my total circumference divided by 4, into my 4 equal pieces. So I can just go ahead, it's already in there, divide by 4, and that's going to give me my arc length as 5.652, or 5 and 652 thousandths of a meter. That's my arc length from A to B. Not too bad. You guys already know how to do circumference. So we just have to then just take a piece of it. Not too hard. Arc length. Super awesome. This one is even easier, because this one gives you your diameter. So you can just go right to it on the circumference formula. We can go ahead and say, hey, I need 3.14 times my diameter, 12. I go to my calculator, dun, 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 dun. I do 3.14 times 12. It gives me 37 and 68 hundredths. And this time we're talking about millimeters. And now if I look at how many equal sized pieces did I divide my circumference into, I have my one piece from A to B, and then I have another equal sized piece. So it's just 2 pieces. So that means I just have to take my whole circumference and divide it by 2 equal pieces. I hit divide by 2, and I get 18 and 84 hundredths of a millimeter. Super perfect. That's arc length. Not too bad, right? Not too bad. Go to work, mathematicians.